How you doing, everybody? Randy Richard in the shop, and today we're going to finish up the Clausing lathe. It's a long time coming, so this is part 12 of the Clausing lathe repair, and be sure to check out the previous videos to see where I left off, but we're going to finish it up here today and turn apart. How you doing, everybody? Randy Richard in the shop. We're finally going to finish up the Clausing lathe here today. This will be part 12. It's been taken over a year to get everything done on it, and we're going to get the intermediate cross shaft put together and installed and up and everything running here. The electrical's already done, so be sure to check out the previous videos on the build. They're all in a playlist on my channel there, so I'll put a card up in the corner to the playlist. So be sure to check those out and see where we left off and all that good stuff. And we'll turn some metal with it too. So stay tuned here and let's get started on it. So we're back on the Clausing finally. Okay, so we got a few things to show you. So we're talking about the cross shaft, and this is where I left it off, right here, where we have new bearings in it, new bearing in this is the brake, this is the friction and the disc, and there's a bearing inside this block, and I could not get that original bearing anymore. No one makes it, so I modified it to fit a new bearing, and I had to make a new piece here that engages the clutch. This is the clutch. You know, we'll hold that up a little closer there. So we made a new piece, and see the other videos, you'll see all that. And we put this all back together so far. So my dilemma came to the pulley that goes on here, the other Reeves side. Well, this is completely trashed, this one. This is the one that came off, the original. This has been welded up, the keyway, I don't know, 1, 2, 3, 4, 5, 6, 7 times, and then they put in a huge one, 1/2 inch wide. You could see all the welding that was there. There's a keyway, all welded, all the way around this thing. This is all cast iron, all one piece, and there's bearing that goes in here. And then they chopped a big old gaping hole in it for the keyway. Right, and then there's a anti-friction sleeve that goes in here, and this usually has a coating on it, an anti-friction coating. So anyway, this is basically unusable unless I chop out the center and redo this whole mess. Well, my friend Dale Deary, and he was helping the guy clean out his shop back east, and he came across some parts for Clausing lathe. And so he shipped them all to me. I bought them from him. Yeah. Anyway, and I was going through them, and well, here's the right size pulley. I cleaned this all up. I go, well, it's a kind of screwed up here. The keyway's all been wallered out, but not undoable, and put a new keyway in. So I could have fixed that, but this piece, it's kind of different. Here it has the anti-seize coating, has a key in it, which is all worn out, but it came in 2 pieces. Somebody used the old Tony method and karate chopped that right off of there. Why'd they cut it? Who knows? You know, the bearing was in here. It was pretty frozen in there, so I made a plug that just fit in there because it just barely caught on the edge, and I was able to push out that bearing. That's what this was. So I was thinking of, well, I could put that back together, you know. I was thinking of, instead of ruining the anti-friction coating, I was thinking of putting 6 1032 socket head cap screws down through here and screw that on. Put a new key in, fix the keyway, and put a new bushing in. You know, make a new Delrin bushing, and I could have made this usable. No, we're not going to do that. Then I was going through my stuff there, And this one was all put together. And it's in fine shape. Actually, fine shape. This has the original bushing, original part bushing in here. Now, I don't know what this is made of. It's pretty hard. A lot of people replace this with Delrin, but this one's in great shape. I cleaned this all up. It's pretty nasty, but I cleaned it up. And this side is in good shape too. The coating's even in good shape. The key's in good shape. So I cleaned it all up. So this is what I decided to use. And there was no bearing in here, but it was kind of nasty and rusty. But so I've got it all cleaned up. So that's going to go on there. That's going to go on there. And I cleaned up the kind of a heat sink fan. It's a piece of it's aluminum. Goes on there. Spring goes on there. And then the book. I have an original book, and this is a copy of the drawing. And it shows using this style cap here for the spring. So that the keyway was for the original one. They had really hollered it out, and it was all mangled. So I just cut a small keyway notch in it with a file, right there. And now we'll push down, and that'll push all the spring on down, and then going down in here, and then there's a snap ring that will go down in here and it holds this all compressed on here. So that'll be a little bit of job. Now the other springs I have are a little lighter weight springs, but this is the original spring that came with the lathe. Heavier weight spring, has more coils, so we'll use that, and we'll use this and snap ring, and then it all goes back on the shaft. And I have, of course, new bearings for it, and already put a new bearing in there, and a new bearing on the end of the shaft, and this pulley and spacer, and it goes back in the whole carriage assembly, and we'll get it all back together, and we're going to get this thing running finally. Thank you, Dale, for sending this. I don't know why I did not see this one originally. I saw that pieces, but I don't know why I didn't see that this was all put together and ready to go, usable. Not ready to go, but usable. So bingo, it's all together. Now you're wondering how I did that. This was far easier than you might ever have thought. I took another one of these. I have 3 of these things. These fans, right? So I put it over the top of that. I stood on this, and I was able to compress that down enough. I was standing on it, my big fat butt, and then my wife just reached in and put that snap ring on there. Bang! First try, just like that. She just took that snap ring, boom, slipped it down there, and let go, and it was in. Good thing you got a wife that can do something. And so that worked out just perfect. So this assembly is ready to go, and we'll put it on the shaft. So this is really pretty simple. This just slips on here, just like that. Now I think, yeah, that a little bit of key way down in there. There's a key slot in here that it needs to slip into and engage. When I took this apart, it was very hard to get apart because of that. So that has to slip down in there into the clutch mechanism, which doesn't want to just slip. The 3/16 key right here into this keyway. Well, we'll work on that off. We'll work on that off camera. Get that to fit. All right, I got this slipped on there. I just dressed up the end of the key with a little file, a little bevel on the end of the edges, and just tapped it. And it tapped on. I had to tap it on with a hammer though, so it's a very nice snug fit. But it went right on. And Then we have bearings. So these are brand new SKF, made in the USA bearings. And hopefully they should slip right on here. Yep. And my little pipe here, a little tap it down in there. The whole assembly just spins on there like that. And we have this pulley goes on, and it goes on a keyway. Then we have a key I already previously made. It goes with a brand new key. This slips on here like so. That went. Oh, okay. I never trimmed it to length, I guess, because I wasn't sure how this was going to be. So we need to trim that because a spacer goes on here up against the pulley. So I got to trim 1/8 of an inch off of this. Scribe, and we'll scribe that. There we go. And we'll just trim that off. Okay, in there with the new key trimmed off. Spacer goes on. Another bearing. Yeah. Now these all came wrapped. I just previously unwrapped them. That's all. Here. Catch it before it rolls away. Just like that. Oops. There we go. Alright, using this original spacer, we ended up with about, not quite a 1/2 inch, maybe 3/8 of an inch extra room. I don't know why. Everything's together right. Everything fits in the carriage right. So, I'm not sure what the deal was with that. Anyway, magic of video, new one, and fits just perfect on there. And then we'll slip the bearing on here. There must be a little tiny burr on that edge, but it goes on there just nice. Yeah, must be a little burr out there. And then, of course, the snap ring goes on. There we go. Okay, so I just left a little tiny bit of movement for that, which will be, yeah, that way if it might need a little bit. I don't know, but that's not very much. Maybe 20-30 thousandths there, 20 thousandths. So this is the carriage goes into. I need to clean this up. It's pretty dirty. Let me go get it clean. All right, all cleaned up. We're just gonna set this in here. Now, this has a really poor method back here on this end. Really poor method back here to capture the thrust, back and forth actually on the shaft. They put a snap ring in here and a snap ring out here. Really kind of sucks, their method of doing this. And then the bearing cap has two also grooves for those snap rings. Now doing this in a lathe, taking this off, or very difficult to reach this end. It's a real pain. So I'm going to put this on now. This way. There's a couple locating pins. I'll put this on now, but I'm not going to put it tight because we have to loosen the other end to lift it to slip the belt in. once you have this all in place. So we'll just get this in here and started. Tap it down. And we'll slip this ring in here, this end. And then we're going to capture them. Like so. We'll capture them and get the bolts in here started. That way we just got to tighten them up after we're going with them here. So you can see here how the clutch and brake mechanism, I just showed you how that worked. So that's engaged, and then this way is braking and disengaged. So you can, let's see, we'll zoom that out. So right there the motor is turning, yes, it's disengaged, the brake is holding the spindle. And this, I adjusted it here so there's some friction. I don't know how much I'll need, but there is pretty good friction there now. And then when you go engage, it locks the clutch back together, disengages the brake, and everything's bound together to turn the spindle. That's about it. We just got to put it back in the lathe now. One other quick thing here, once we have it back in here, there's just a few thousandths of end play here now. That evidently moves and adjusts the position here, and it took up that 20-30 thousandths I had. Just really nice. There's still 20 thousandths on the snap ring end here, so for a little bit of expansion room. So no big deal. This is not captured in this housing. It can slide the bearing. I guess as it gets warm, it might expand a little bit. But anyway, so that worked out real nice. All right, I'm working in pretty tight quarters here. This is our drive belt for the motor, and this is what we repaired before. This pulley, this Reeves pulley. So that belt goes on there, and that will reach up to the other Reeves pulley. And above here is the drive belt to the spindle, and that will be hanging down here, and we'll hook it onto the drive pulley of the carriage here, or the intermediate shaft. Now we're going to slip this up in here. We have these are two studs, one set on each side. They're hooked with a bar. They're into a bar in the back here, which is captured. So it slides up and down but won't fall out. They're studs. So we're going to slip that up in there. We'll get these on here. Then we'll get our belts on, and then we'll adjust the height of it to whatever it needs to be. And get things adjusted and running here. Since, electrically we're all hooked up, it's all ready to go. It just needs this put back in. We also have our linkage to put back together. We have our handle for this to put back on. This is our the change box part of that engagement stuff, and we have a link to put in for the brake and engagement. So this will all work again. This wasn't working before because the link arm was gone. Watch the previous videos, and what I did is I made an arm here for it, and we'll be putting this in. This is a very tight quarters here. I'll be doing this. We'll just get it up here and get these things started before we do anything tightening. And actually, I see right now I need to put washers on these, so we'll get them all set here, started, and then I'll go get some washers. There we go. There weren't washers here before, but they should have washers. Okay, washers are on. I know this is really hard to see, but it's kind of a dark corner. Anyway, what we need to do is we need to get this big belt, this belt, over that pulley first. That's why we left all this kind of loose. Hopefully. Yeah, that's still not enough. So I'm going to have to loosen those up in the back even more. Alright, so I've been fighting this. The belt, this belt here, on the Reeves pulleys, the bottom one works great. There's zero problems with that. That's the hydraulics driving it here, this double piston. I put in the spring that came out of here on the intermediate shaft, and I cannot get this pulley to open. This opens as you collapse this one. It pulls harder on this one, and this opens due to the tension being pulling the belt down into the pulley and spreading it apart. You're pushing against the spring. Well, that spring is so stiff that I cannot get this belt down in the pulley at all. You know, I got it pried back a little bit right now, but I cannot get it to start down all the way down in there. Just barely. It doesn't even barely start into the pulley. And I've tried to pry it open. It slides fine. It slides and does move. But I got to put a pry bar in there and pry it, and it's very stiff. So I've tried this about 3 times, and I'm kind of tired of fighting it. So I'm going to pull this out. I'm going to put the other spring in, and then we'll put it back in again and give it a try. I cannot get this to drop down in that pulley at all. This is just all too tight. You're fighting all this with both belts, and I mean, this belt is tight. And so I'm gonna try the other spring. All right, I put the lighter spring on, and put this all back together, obviously. And I have the belt in here. With much frustration, still barely being able to split that open, I did finally come up with a method to get this open and get that belt down and started in there. So what I did is I cut a little piece of pine block. It's about 1.5 inches by 2 inches by 3/4 thick, to fit in down here in between the 2 Reeves pulleys, and I put it up in there upward in between the upper Reeves pulley, and then I took a pry bar underneath here and pried it up like that. Split that right apart. Boom, boom, a couple taps with the old dead blow, and the belt's in. The block falls out, and you're good to go. Just slick as can be. I probably could have done it with a stiffer spring. Well, so we'll see how the lathe goes. Whether we need the stiffer spring in there or not, I don't know. But we're going to give it a try. So I don't have the spindle engaged right now. We're just going to turn it on. I don't know if you can hear it, but that is dead quiet. Not even anything close to how it used to be. Now, we're not running very fast, but... And that's full 60 cycles on there. I don't know, can you see how the Reeves pulley works? Just smooth as can be. We're talking smooth. That's pretty much full speed there. And that's all the way on the Reeves pulley and 60 cycles on the motor. Just smooth as now. VFD works. We can dial it down. We have infinitely variable speed now. Oops. Just fantastic. That was in reverse. This is in forward. Now I'm going to engage the, we'll engage the chuck, or spindle. There we go. Spindle's engaged. Very, very smooth. Now we just gotta, we'll get the linkage put in for the clutch and brake mechanism. Now we got the, this is the linkage that I built that was completely missing. So we're going to, we even have a couple helicopter parts here. Right here, little ball joints. We're going to put those in and we'll test her out then. Alright, I have the linkage in and adjusted, and yeah, I think we're ready. So that's forward, and the spindle's not turning. Spindle belt here is not turning, and all we do is pull the lever over here on the carriage. I'll show you that, and it engages, and the spindle's running, and down, when you disengages the clutch, and the brake brakes the spindle. Isn't that sweet? And you can just leave it run. It's incredibly quiet. And of course, do it forward. It doesn't matter forward or reverse. That's engaged, and that's disengaged. And I'll show you the other controls. Alrighty, here's the hydraulic part of the speed control for the Reeves pulleys. This is the forward and reverse and off selector. Now I reconfigured the switch so it sends a signal to the VFD for forward and reverse operation. Instead of having, of course, a three-phase switch back there, like I said, I kind of reworked it and reconfigured it so it does what I want it to do. And down here is your clutch brake engagement lever. So down is disengaged and up is engaged. Now that has a shaft that goes along here to a handle also on the carriage over here that does the same thing, right? So that's kind of nice having two handles. So you know we'll have it on, the motor's running, but nothing else is running. We're in forward, we'll engage, and there the spindle is now turning, chuck's turning. Stop, and you get a relatively quick stop. No matter if you push a little bit on it, you get a little stop, little faster stop. And then if you for higher, you can also change your speed here. You know, you can raise your speed up. This, I have to tighten that spring that's inside of here. It should counteract this pressure that's acting on it and pushes it down. I need to get that spring a little bit tighter. Now we're only running about 35 hertz on it right there, so yeah, about half speed. At the 600 and tax on, it's 628 RPM. Right there, spindle speed. And actually, my little dial here says 600, about that, right there. Go 60 cycles. Now it's 600 here, now I'm showing 1,066 RPM. all that fixed. So what I'm going to do is I'll finish putting the covers on tomorrow, and I'm going to turn some metal on this puppy. Those are really the only things we had to finish up on it, was that Reeves clutch, Reeves the intermediate shaft. So we'll get the covers on. Handle's got to go back on for the quick change gearbox setup, and we're ready to roll. We're ready to roll with this lathe. I really want to try it out. I have a piece of 4140 pre-hardened material in here, 1.25 inches. This is the same material I make dovetail cutters out of. Now, I've made a couple cuts, got my tools centered, and I took the jaws off. Okay, so I tried it with the jaws on, the top jaws, and I got a wavy pattern or a vibration, harmonic pattern in here. And so I took them off. I slipped a feeler gauge in, and just the very first serration was able to get a feeler gauge in at 1.5 thousandths. So the rest of the jaws were grabbing tight, not really like it's bell mouthed. So I took them off and grabbing them with the master jaws directly. Now I'm still getting a little bit of the wavy pattern here. That's usually a vibration of some sort. I have no play in my gibs, tool post, everything's tight, carriage tight, everything. I have not leveled the lathe or anything like that. I'm going to move it a little bit in that direction, so I have a little more room, and then I'll level it up. It's a very short lathe, so I really didn't expect to be getting this kind of vibration. So we'll do a cut here, and we'll see how it goes again. The lathe is running great as far as all that goes. So I'm running around 660 RPM, 10,000 speed rate. Out there it's fine. It's when I get a little farther in. Now, then it starts to rub. I don't like that. But now there, that cut just beautiful. That was just a fine fit. That didn't do anything. Let's do that again. Do 20 thousandths again. Same feed rate. Now I'm not getting a good chip break, but the machine is running smooth, very smooth, as far as vibration in the machine. Good finish. Maybe a little bit of harmonics in that last part. So, if the machine's not squared up, these are very rigid machine anyway, but we'll do a leveling on it to make sure we're cutting squarely. Now, as far as adjustments, like on the head of this machine, there might not be much of anything at all if I have to square the head up a little bit. The headstock sits on the V-way. That's very, very much a difficult thing to do with sitting on a V-way. But hey, the machine is running, and we'll move it. We'll get her leveled up, and we'll come back to it. I want to say this has been a great success as far as all the other repairs go. So, as far as all the repair stuff goes, we'll say it's good, and we'll go from there. We'll wrap up the repair project for this. You know, the rest is a setup thing and setup issue and figure out what's wrong. Maybe I'll have to get a different chuck. Maybe I'll put a different chuck on. This has the L00 mount. This is the same mount as my big lathe. This is an 8-inch 3-jaw. Maybe I'll try a different chuck on here, and we'll see how that goes. But thank you guys, and thanks for watching, and I hope you enjoyed this series. A lot of repairs to the lathe, and I think all the repairs themselves are great and fine. So this is more hopefully of a setup thing. I think the bearings are fine in the machine. There was a lot of end play, and I retightened the bearings. But other than that, thank you guys for watching, and please subscribe. If you want a dovetail cutter or scribe, email me. I've got everything in stock still. There's going to be a bit of a break on things. I'll be gone for a little bit, a couple weeks. Got to go fishing. So thanks you guys, and thanks for watching.